Hello and welcome to week 7. This week we're going to be doing some data visualization. This week we'll be covering how to graph data on scatter plots using Matplotlib and Python. We'll learn how to plot our OLS regression models. We'll customize our plots in Matplotlib. We'll combine plot elements to create multiple plots per chart. And finally, we will export our plots to image files for use in other programs. Let's take a look at our challenge this week. Back in week 2, we demonstrated a relationship between smoking rates and the incidence of lung cancer deaths in Canada. Now we have been asked to produce graphs of the data for an upcoming presentation. We need to produce 3 graphs. A scatter plot of smoking rates versus lung cancer deaths, a line graph of smoking rates and lung cancer deaths over time, and finally, we want to plot our regression line from our smoking regression model to demonstrate how well our model fits the data. Let's remind ourselves of our data file. We'll be working with Table 1 smoking versus cancer.csv, and this lists Canadian smoking rates versus lung cancer deaths per 100,000 people age adjusted. Now remember, this is the same file that we used in week 2 to run our original regressions. The data sources are listed below. Remember back in week 2, we imported the pandas library to read, write, and transform our data? We've been typing import pandas as PD at the top of all of our files. It's time for us to use a new library, Matplotlib. This is what we'll use to plot our data to the screen. There are lots of plotting libraries out there for Python, but I find that Matplotlib is the easiest out of them, especially for what we'll be doing. If you want to check out more details, go to matplotlib.org. Our first plot is going to be simple. We are going to plot the year and the number of smokers on a scatter plot, year along the x-axis, smokers on the y-axis. First thing we need to do is import the Matplotlib library with an import statement. We'll put this at the top of our file, right underneath import pandas as PD. We'll type import matplotlib.pyplot as PLT. Then, as always, we read in our CSV file as a data frame, and then we can create our first scatter plot. So let's get Python ready. You want to make sure that you import pandas as PD and then import matplotlib.pyplot as PLT. We're ready to create our first scatter plot. We'll create a variable here for our x-axis. So this will contain our x-axis data, and it will be our smoking data, the year column. And we'll create a variable for our y-axis, and this will be our smoking data, smokers. So nothing new here. We're just extracting our columns, getting them ready for use in our scatter plot. To plot a scatter plot, we will use plt.scatter. Our first parameter to the scatter function is what are we going to use for our x-axis? In this case, we want to use our x-axis variable. Next, what do we want to use for our y-axis? And we'll use our y-axis variable. If we run this code and go to the plots pane, you'll see a very simple plot. Y-axis represents our percentage of smokers. X-axis represents the year. This is okay, but our graph lacks context. There's no axis labels and there's no title. Fortunately, we can add these via the X label, Y label, and title functions in Matplotlib. So to add an x-axis label, we'll call plt.xlabel, pass in the label, in this case year. For our y-axis, we'll call plt.ylabel and pass in percent smokers. And finally, we'll give this plot a title, smoking rates in Canada by year. Let's try it and see what happens. So we'll call xlabel year, plt.ylabel, percent smokers, and plt.title, Smoking rates in Canada by year. Matplotlib has given us a new plot in our plots pane. Smoking rates in Canada by year, percent smokers, and year. You can save this plot by right-clicking on it and clicking Save Plot As. If you're working in another program, say PowerPoint or Apple's Keynote, and you want to copy and paste the image into that program, click on Copy Image. That will put that plot in your clipboard. We've created a basic plot. We've given it context. Now, let's increase the readability of our graph with grid lines. By default, we can add a muted gray grid via the grid function. Let's try it. So after adding our title, we'll call plt.grid. Notice how we have a muted gray grid just in front of our plot. A tip that I've always abided by is one from Edward Tufte, the author of The Visual Display of Quantitative Information, a fantastic read for anyone that's getting into graphic design. His quote is, above all else, show the data. We want to provide grid elements that help convey the story that we're trying to tell about the data. Our grid lines give us a nice muted gray. It's just present enough that it helps guide our eyes, but it doesn't distract from the meaning of the data. In our previous grid, we accepted the default gray that we got. You might want to tweak this color depending on the final medium that your graphic will be displayed upon. For example, if you're displaying your visual on a projector in a room that has bright lights, you might need to make those grid lines darker in order for them to show up on the screen. Likewise, if you're sending your document off to be printed by a professional printer, you could get away with a lower contrast set of lines because the print quality is that much better. It depends on your final medium, and I suggest that before you present or share your findings with other people, always try to test out what your visuals will look like on the final medium. It turns out that we can customize our grid lines by specifying a color to use via the C or color parameter. For those of you that have written HTML or CSS cascading style sheet code before, we can specify our colors in CSS hexadecimal format, or if you're not comfortable with that, there are some named colors that Matplotlib will recognize. You can find out more about those at the named color reference chart, but for now, we'll make our grid lines light gray using the C parameter. So we'll come back into Python, and in plt.grid, we'll say C equals light gray. And if we run this code, you may notice a subtle difference between our original grid lines and the new grid lines. I'll flip between them here. Depending on the screen that you're looking on right now, these grid lines may appear more or less different. I'll put them side by side so that you can have a comparison. I suggest that you pause the video. Take a look at the graph. Which one guides your eyes better? Which one is less distracting? Now, you may have noticed that our grid lines have been drawn over our data points. By default, Matplotlib is going to draw the grid lines over everything else. However, if we want them to be in the background behind our data, we need to manipulate what's known as the Z or Z order. Items with a lower Z order on our graph will be drawn first. So we want to draw our grid, give that a Z order of 1, and then to draw our points on top of that, we provide Z order equals 2 to our scatter function. Let's try that now. So grid will receive a Z order of 1, and scatter will receive a Z order of 2. And if I flip between the two visuals here, you'll notice that in the before visual, the grid lines are appearing over the data. In the after visual, the grid lines are appearing under the data. Plot elements with a higher Z order or Z order will be drawn over top of elements with a lower Z or Z order. One other element to consider when we're sharing our graphs with other folks is that in our plot pane, we have a small dimension to fill. Our graph is going to be small, and with extra data, it's going to become cluttered quick. If we export or copy our image to the clipboard and then try to scale it to fit a presentation, like a PowerPoint or a Keynote presentation, it won't scale well. It can become very blurry. We can control the size of our figure by using the figure function and specifying our desired size in inches. So we can make an 8-inch by 5-inch graph with the following code. So I'll come up here and I'll say plt.figure and say fig size equals 8,5. Now the difference here is subtle, but you can notice how the titles seem to get smaller, but the graph got larger. This is now an 8-inch by 5-inch graph, and it can be easily copied into other programs without any loss of quality. That's the basics of making scatter plots in Python. In the next video, we're going to plot our lung cancer data.